Okay, so something I've decided to do in this class, I'm going to go through and do some of the homework with you and just give you a video of how to go through those homework questions so that when you get stuck, you can go through them. But please be careful not to just copy down work. You really do need to pause the video, think through the next step as you go. And so kind of keep that in mind as you go. This is 1.6 that we're going to be working out of. And we're doing 2 through 10 even. So question number 2. An object that is thrown straight up falls back to the earth. This is one-dimensional motion. When is its velocity 0? Question number 2, part A. An object thrown straight upward would have a velocity, because it's going to come back to the ground, have a velocity of 0 right up at the top, okay, or at its vertex. There's a moment when it just pauses momentarily. Part B. Does its velocity change direction? The answer would be yes. Initially its velocity is upward, then its velocity is downward. And then for part C, does the acceleration due to gravity have the same sign on the way up as on the way down? That answer is also yes. The acceleration is always downward, okay? So it's always negative in a typical case. If the ball's going up, that's its velocity, not its acceleration. Its acceleration is still pointed downward. So that should help us with question number 2. Let's look at number 4, where we have at the beginning of a basketball game, a referee tosses the ball straight up with a speed of 4.6 meters per second. So if we're thinking about our values here, that means the initial velocity is 4.6 meters per second. And we're told the player can't touch the ball until it reaches its maximum height. Now, at the maximum height, we just said there's a point when the velocity is 0. So that's what we're going to use there. Gravity is the acceleration in an object in free fall, so that's negative 9.8 meters per second squared. And the question we're being asked is, what's the minimum time the player must wait? So we don't care, right now we're not asking what's the height, although we should be worried about that, because if the basketball player can't jump that high, that tells us a little bit about when they should time their jump. But assuming that it's within reach, how long does a player have to wait before they touch the ball? Now they're going to want to jump before this point, but we want to time that just right. And so we're looking for the time here. Using a kinematic that doesn't use delta x would be our first kinematic, v equals v naught plus at, where our final velocity is 0, our initial velocity was 4.6 plus a negative 9.8 times t. To solve this, we're going to subtract the 4.6, and then we'll divide by negative 9.8. And our time should come back to roughly 0.47 seconds. Okay, let's clear that and start for the next one. Now number 6. Okay. Number 6 says a diver springs upward with an initial speed of 1.8 meters per second. So there's a v naught of 1.8 meters per second, and that was an upward jump. We're told that they're from a 3-meter high board. Okay, so now that we'll get to in a second. If you want to look at the picture of it, that means it's 3 meters above the water. Okay, so this is the diver here. Diver's going to jump up and then come down into the water. Find the velocity with which he strikes the water. So that would be a velocity down here, a final velocity. And what's the highest point he reaches above the water? So the next question is, what's the height at its highest point? Or not delta x, but it'll be close to delta x. We know it's going to be something above 3 meters. So the first thing we're going to do is we are going to go through v naught. V is our big question. A is, of course, negative 9.8 meters per second squared. Delta x. Now, this delta x is not going to be the height. Remember, delta x is a displacement. Because of the fact that I'm starting on the diving board and I'm ending in the water, that is a negative 3 meter drop. Now, I know the diver is going to cover more distance than that, but in terms of overall displacement, that's all I have. And then time, you know, again, there's that, it's not given. But I don't need it. I should be able to solve for V using just that information. Using the third kinematic, V squared equals V naught squared plus 2a delta x. We have V squared equals 1.8 squared plus 2 times a negative 9.8 times negative 3. If I put all of that in the calculator and take a square root, the calculator is going to give me a number of 7.9 meters per second, roughly. But I know that that number should be negative, specifically because I am headed down into the water. Now, if I'm asking about their speed, it's 7.9 meters per second. If I'm asking for velocity, I really need to include direction. And so we're going to use that negative to imply that the diver is moving down through the air. All right, and then the last part of it is, what's the highest point that he reaches above the water? Well, I actually have to change some of the information. Specifically, V naught is still 1.8 meters per second. But V is not going to be this negative 7.9. I'm going to put it at 0. That'll tell me when is it at its high point, when the height, or when the velocity is 0. Acceleration is again negative 9.8, and I'm looking for delta x here. So to solve this one, we'll go to kinematic number 2 again, but we're going to solve for something different this time. We have 0 equals 1.8 squared plus 2 times negative 9.8 delta x. To solve this, I'm going to subtract the 1.8 squared. Maybe I'll grab a calculator just to run through it. 1.8 squared. Okay, I need the negative of that. And then I want to divide that by the 9.8 times 2 is 19.6. So I'll use a negative 19.6. And that gives me a delta x of 0.165, which seems wrong. What did I do wrong? Let's see. We square the 1.8, that's our V naught. Our final velocity should be 0. 2 times the acceleration. Where's the highest point? Oh, above the water. Well, we have to remember this is 0.16, look at that again, 165 meters above 0. Well, we said 0 was going to be right here at the board, okay, above the board. That's where we measured everything from. So if I add that to 3 meters, we get roughly 3.2 meters. And that's how high above the water the person is at their high point. Question number 8 we did in class. Let's do question number 10. You know, I think we're going to stop there. Hopefully that's enough to get you what you need for this assignment, and we'll answer the rest of them in class if you still have some.